Good day. This is a quick PowerPoint looking at two tables of reduction potentials. This one is from the back of your textbook. So if you're doing textbook questions or certain worksheets that have numbers like this on them, you're going to use this table of reduction potentials. And you also have another one that's for other worksheets and whatnot. And it's also the other one is the type you'll use on the final exam and unit tests and things. So when we look at it, what it tells us is all of these forward reactions have electrons to the left of the arrow. And what that means is all the forward reactions are reductions. We're getting a drop in charge. So if you looked at something like silver, at spot 0.80, it's going from +1 to 0. And what you see on the right is it gives you the voltage for that. And in physics, they like to call it, rather than voltage, they like to call it electric potential. So this is why it's called reduction potentials. All the forward reactions are reductions. You're getting a drop in charge. These are all called half reactions. And what we're eventually going to be looking at is combining these. So you'd have a reduction, a forward reaction, and you combine it with a reaction going the other way, half reaction going the other way, which would be oxidation. You might say, well, why don't they give us two charts and have one just for reductions and then flip this all around and have one for oxidation? Well, you're going to have to get used to using this both ways. But anyways, these are the sheets that will come in handy. This one is in your package, and like I said, the previous one is at the back of your textbook. A lot of the things overlap. This one just has a few more examples, especially up near the top, that come in handy. Later on, we talk about oxidizing agents and reducing agents. So up to the upper left are the strongest oxidizing agents, and they get weaker and weaker and weaker because this voltage goes lower and lower and lower and gets very negative. And over here, we get the strongest reducing agents, or bottom right, and gets weaker as we go to the top. So remember, this forward reaction says minus 3.04, so if we're going the other way, that would be plus 3.04. So if we look at oxidation, we end up flipping the charge. Again, if this is a little overwhelming, don't panic. This is just an intro, and you will be seeing this again, and I will go over it again.